All right, welcome, focused learners, to today's explainer. Listen, if your ultimate goal is to become a Java developer in 2026, but you're sitting there feeling completely paralyzed by where to start, what to learn, and in what exact order to learn it, you are in the exact right place. Today, we are walking through a highly structured, step-by-step roadmap, and this is going to take you from an absolute beginner to a super confident backend or full-stack developer.
Because, let's be honest, most beginners fall into this massive trap: tutorial hell. We've all been there, right? You waste months endlessly watching random tutorials online without actually building any real muscle memory for coding. It just creates this illusion of progress. Well, this roadmap is the complete opposite. It's a direct, actionable path intentionally designed to prepare you for actual placements, internships, and high-paying software engineering jobs. We're only focusing on what genuinely moves the needle.
So here's how we'll break down our journey today. We're going to start with why Java is still so relevant. Then we'll build your foundations, assemble your developer toolkit, explore real-world backend development, and finally, we'll wrap up with projects and deployment.
Okay, let's kick things off with Section 1, why Java in 2026?
I mean, it's the most obvious question, right? With so many trendy new programming languages popping up literally every single year, why should you dedicate your valuable time to Java? Right now, here's a kind of funny fact. People have been predicting the end of Java for, over a decade? Yet the reality is entirely different. Java remains one of the most powerful, battle-tested, and heavily in-demand languages on the planet.
The truth is, big companies worldwide simply rely on Java. They use it for massive backend systems, highly secure banking applications, complex enterprise software, and incredibly scalable cloud platforms. And even more importantly, Java is frequently the essential backbone for modern tech like Spring Boot, microservices, and even AI-integrated systems. So for hiring managers trying to build highly scalable apps, freshers with strong Java fundamentals aren't just an option, they are highly preferred. If your goal is securing a top-tier software engineering job, Java is an incredibly safe, lucrative bet.
Moving right along to Section 2, Foundations. This is where we lay the critical groundwork.
Before you even think about jumping into those fancy frameworks, you absolutely must master core Java. I see so many students rush this crucial phase. They'll literally sprint directly into Spring Boot without understanding the basics, and they always hit a massive brick wall later on. Don't do that. Start strictly with the fundamentals: variables, loops, arrays, and functions. Practice these by building small, tangible things. A number palindrome, a factorial, or a simple command line calculator. This is the only way to really build your underlying developer logic. And please, if you take one thing away today, burn this quote into your memory. Coding improves only by writing code, not by watching videos. Active practice is the absolute only way to genuinely build your programming brain. Watching someone else effortlessly solve a problem on a screen, sure, it's easy, but it won't help you at all when you're staring at a blank screen, sweating during a technical interview. You gotta put the reps in. Now, once you have those basics down, you graduate to Object-Oriented Programming, or OOP. This is where almost all fresher interview questions come from, but please don't just memorize textbook definitions. You really need to understand the why behind them. Take inheritance, for example. Think of it like a master blueprint. It exists specifically to reduce code duplication, completely stopping you from rewriting the exact same logic over and over again for different parts of your app. Then we have abstraction. Think of this exactly like driving a car. You don't need to know how the fuel injection system works just to turn the steering wheel and drive to the grocery store, right? In your code, abstraction hides all the complex, messy implementation details, so it only shows the user or other developers what they actually need to interact with.
Next up is encapsulation. You can just think of this as your code's own strict internal security guard. It's how you protect sensitive data within your application from being accidentally accessed or, worse, maliciously modified from the outside. It just keeps your code safe and totally predictable.
And finally, polymorphism. This one dramatically increases flexibility. It allows different objects to be treated as instances of the same class, kind of like how a phone and a laptop can both be functionally treated as devices on a network. Understanding these OOP concepts deeply makes jumping into backend frameworks infinitely easier later on, simply because those frameworks are built entirely on these exact rules. All right, let's move into Section 3, the Developer Toolkit. These are the practical, day-to-day tools you need to actually pass interviews. So your toolkit is fundamentally split into two main areas. On one side, we've got the Java Collections Framework, things like ArrayList, hash maps, queues, and streams. You need to understand their time complexity and internal workings. Hash maps, for instance, huge interview topic because they are the ultimate real-world tool for super fast data lookups. Now, on the other side, we have data structures and algorithms, or DSA. Start simple here, focus heavily on arrays, strings, hashing, linked lists, and recursion, way before you attempt anything advanced. Look, a lot of beginners are totally terrified of DSA because they try the absolute hardest problems way too early in their journey. Seriously, don't do that. Reassure yourself by starting simple. Solving just 1 or 2 problems daily on platforms like LeetCode or HackerRank is more than enough. But you want to know the real secret to growth here? Focus entirely on understanding the underlying patterns, not just mindlessly memorizing the answers. This phase is non-negotiable for passing technical coding rounds, so just make it a daily habit. Section 4 is where things get really exciting. Let's talk about real-world backend. So, after mastering DSA, you absolutely must learn SQL and databases. Why? Because this is where your code finally meets reality. Backend developers work with databases constantly. You need to learn fundamental commands, stuff like select, join, and group by, alongside standard database normalization. Then you learn how Java actually connects with these databases using JDBC. This is the magical moment where your code starts interacting with permanently stored user data, rather than just floating around in temporary memory. From there, you graduate to Spring Boot. And this framework is brilliant because it removes the headache of manual configuration, so you can actually focus on building modern apps. You'll need to learn the absolute essentials here: building REST APIs, routing web requests with controllers, writing your core business logic in services, and seamlessly managing database records with Spring Data JPA. Then you level up by adding JWT Authentication and Spring Security to expertly manage exactly who is allowed to do what in your app. Guys, this is exactly how industry-grade microservices are built today. And finally, we arrive at Section 5, Projects and Deployment. Honestly, this is the crucial step most beginners completely ignore. At this stage, you need to prove to hiring managers that you can actually do the work. Projects teach you vastly more than tutorials ever will, and they are exactly what make your resume totally irresistible to recruiters. You should be building concrete, functional things from scratch. Build a secure authentication system, a full e-commerce backend, a student management system, or maybe a complex URL shortener. You really need to show them you can handle complex business logic. But here's the catch. Building the project on your local laptop isn't enough. You have to deploy it. The exact workflow recruiters absolutely love to see looks like this. First, use version control with Git and GitHub, which proves you understand commits and branching. Second, push your code to a live repository. And third, actually deploy your project online, using platforms like Render, Railway, or Docker containers. Having a deployed, live project proves you understand how real-world developers get their apps out of their laptops and into the hands of real users. So, to summarize this entire roadmap, please pace yourself. Don't try to cram all of this into one stressful month. Focus heavily on daily coding practice, gradual incremental improvement, and relying mostly on building real projects. If you stay consistent with this highly structured path for 6 to 12 months, your skills are going to improve massively, and you will be completely interview ready. So I'm going to leave you with this provocative thought to kickstart your active learning today. Looking at everything we've meticulously covered, what specific project are you going to build first? Think deeply about it, pick one right now, and go write your first line of code. Next time in our Explainer series, we are going to dive much deeper into those core Java OOP concepts in the simplest way possible. Thanks for hanging out with me today, and keep building.